Hi class, this is your physics video for Tuesday, September 29th. I want to continue working a little bit more with velocity time graphs, VT graphs, and position time graphs, PT graphs. So what I'm doing here is I'm going to step you through the step-by-step how to do each one of these. And there's really only 3 steps that are involved in going from one graph to the other. Here are the steps. If we're going from a velocity, if we want to create a velocity time graph and we're given a position time graph, how do we do it? First rule, I want you to break up, first step, I want you to break up the graph into segments, right? So break up the graph into segments. How do you know when you have a different segment? You'll see the slope changes. So here's segment A, segment B, segment C, segment D, E, and F, right? So each time I've got a different letter here, we can see that the slope has changed for that segment. Now we need to calculate the slope, step 2. So here's the slopes for the first 3 segments. Remember how we calculate the slope. We take the ending y, in this case it's 4. There's a 4. We subtract the beginning y, that's 0. So 4 minus 0 goes on top. Our changes in y goes on top. Our bottom is a change in x. Where did it end? It ended at 2. It started at 0, so 2 minus 0. The slope for this one is 2. And we can continue doing that for the remaining line segments. If you look at segment B, we can see that it's flat. Hopefully you know that that means it's got a 0 slope. And we can see that mathematically because y at the end is 4 and y at the beginning is 4. So we're going to get a 0 in our numerator. Keep going on segment C. Where did it end? It ended at 8 on the y-axis. Started at 4. So we've got 8 minus 4 on the top. On the bottom, where did it end? 4 on the x-axis. 3, because where it started on the x-axis, so 4 minus 3. The slope for segment C is 4. Continuing on with the other slopes, right? I'll just do one of these. Slope for segment D. Where did it start? Where did it end, rather? On the y, it ended at 4. Where did it start? It started at 8. So our numerator here is 4 minus 8. Notice that's going to be negative. Right? Our denominator, we ended at 6 on the x-axis. We started at 4, so 6 minus 4. And this is going to give us a slope of negative 2. Hopefully you can see how to do the remaining 2 slopes here. Now that we know our slopes, we're ready to do step 3. On our VT graph, let's place a horizontal line at the value of each slope. So for segment A, right, segment A, its slope is 2. So between 0 and 2 seconds here, we're going to have a red line, our line here for our velocity that's constant, right? It's flat, and it's going to be having the value of 2. That represents the slope of that first segment A. For segment B, what do we see? We saw that its slope was 0. So on our velocity graph, we're going to have a line at y equals 0, velocity equals 0. And it's going to go for 1 second. It goes from second 2 to 3, just like our segment B did. Segment C, our slope was 4, so we got to have our line at 4. It also went for 1 second. Segment D, we saw our slope was negative 2, and that went for 2 seconds. E was negative 4. And finally, F, it's flat. That's going to be a 0 for our velocity. So you see, it's pretty easy to do this. I want you to do a couple of these just as practice. The quiz on Friday will look very, very similar to this. I'm going to want you to be able to tell me how to go from one graph to the other. So let's go look at how do we go, if we're given a velocity time graph, how do we create a position time graph? Well, the rules are pretty similar. In fact, the first rule is identical. I want you to break the graph up into segments. How do we know here how much it's changed? It's when we see a value is changed in our velocity. So I'm going to go ahead and put the labels on the segments. Now it says identify the starting position. And if no starting position is given, you can assume it's 0. All right. For this one, though, I'm going to say we have a starting position of 3. So we know right off we're going to start our position graph over here at time equals 0. It's going to start at 3. Now that we know our starting point, we now have to draw our graphs, draw our lines on our PT graph. And how do we do that? we're going to start at the starting point. Here it's going to be 3. And we're going to have a slope that matches the value on our VT graph. So we're looking for segment A. It's got a slope of -3. So we're going to start off here at 3, because that was our starting point. We have a slope of -3, and we're going to go until we hit time 3. So there is our position part that corresponds to part A, segment A, on our VT graph. We look at segment B. It's 0 for its velocity, so that means our slope on our PT graph is going to be 0. And there we go. Now, if I want to do this more mathematically, I could do it like this. I could say we're going to start for segment A. We started at 3. We went for -3. That was our slope. That was our value for velocity. It was -3, and we did it for 3 seconds. So if we start at 3, we go -3 for 3 seconds. Multiply these two numbers together, you're going to get -9. So 3 plus -9 is going to give you -6. So that's one way to do it mathematically. And then do the same thing for segment B. All right, we ended here at -6. What's our value for our velocity? It's 0. Well, so if we're going at 0 for 1 second, we didn't go anywhere. -6 minus plus 0 still is -6. And we're able to draw our next segment there for B. Let's look at segment C. Well, we know we're going to start at -6. That's where our previous segment ended. Segment C, it's got a velocity of 5, and it goes for 1 second. So we're going to go for 5 at 1 second. That's going to add 5. -6 plus 5 is going to give us -1. So our next line starts at -6 and ends at -1. And we're going to keep doing this to stair step through our work. Let's look at segment D. Well, we know we're going to start at -1. What's our velocity for D? It's 2, and we go for 3 seconds. So if we go for 2 for 3 seconds, that gives you a distance of 6. Right? You start at -1, we add 6, we're going to end up at 5. So we're going to draw our line there that goes to 5. Next segment E, we're going to start at 5. We start where we left off. We're going to go for 4. Our velocity here in segment E is 4. And we're going to go for 1 second. So we have start at 5. We're going to go 4 our velocity of 4 for 1 second. So we're going to add 4. 5 plus 4 ends at 9. And then finally, our last segment, we're starting at 9. Where are we going to go? We've got a velocity of -2. We've got that for 1 second. So this -2 times 1 is going to give us a -2. 9 plus -2 is going to have you end up at 7. Now, hopefully, you also can take a quick look back, make sure you didn't do something silly. We're looking at the slope of this first segment here. It's negative. Yep, our velocity is negative. Slope of our second segment B here, it's 0, so our velocity better be 0. Slope of segment C is positive. D is positive. E is positive. So we better see all 3 of these have velocities above 0. And then finally, we get over here to segment F, and it's got its negative slope. So it's going to have a negative velocity. And indeed, we see that here for F. So that's just a quick review. Hopefully, this makes it a little bit easier to do your conversions from one type of a graph to another. I'll put some sample problems out there. Guys, take a crack at those, and we'll talk more about these tomorrow. Thanks. Have a good one.